Right, hi guys. Good afternoon from a very wet and windy Cape Town here on 25 May 2020. I hope you had a good weekend, and I hope you're ready at this late afternoon time to focus your brains on the next section of grade 11 IT. My name is Mr. Freeman, and we're going to continue where we left off on Friday. So if you've missed Friday, please look at that video as well. When you have a moment. So we're just basically going to carry on implementing functions. Now we've learned all about functions and procedures for the most part of last week. And we are going to do some validation and we're going to implement that into functions. So just to recap on Friday's lesson. So it says they're coding functions to do a basic input validation techniques. So that's just basically where we check any input from an edit, etc., and make sure that what is entered is what is expected from the program or the form, or whatever. So as I said last week, Friday, validation is not necessarily or definitely not checking if it's truthful data that you've entered. There's no ways that I know that if your name is John and you entered John, that I really know that your name is John just using simple validation. For that, you would have to use verification, where we actually go and cross-check using various methods whether the data entered is truthful or not. Now, so what validation does is it just says, okay, basic errors it checks for. Like, for instance, if you got to enter your grade, as I said on Friday, then I would expect you to enter something from 1 to 12 and not Apple or anything like that. So what we did, we covered presence check. So that is a very basic type of check where we simply say, is this edit empty or not? Or are there text actually in there? So that if it's empty, we stop right there. We return perhaps a Boolean in this case, and then the form can decide how it's going to deal with this Boolean. So if it is empty and it's the answer is true, it can decide how it is going to give an error message, maybe through a show message or maybe in an edit or whatever. Then we looked at data type checks, which is the one where my example comes in with the Apple instead of grade 11. So I just make sure that the data type entered is what is expected. In other words, if it's an integer, then you're expecting an integer and so on. And we looked at how to check for an integer as well as a real, and we looked at strings. Now remember, strings are a little bit more complicated because sometimes there's a bit of a tail to that in your exam. In other words, not just necessarily whether it's alphabet numbers, but it could include spaces or any special characters. So you just got to read carefully and stay calm and just include those extra characters that the question would want. But the basic algorithm idea of that stays the same. And you can go and look at the DBE textbook on roundabout page 150-ish, 50-ish of the practical textbook, or you can just go back to Friday's lesson on this. And maybe not a bad idea to go back to Friday's lessons because I did pick up a few tiny errors in the textbook, which I highlighted for you. Then we started off with the range check. In other words, let's stick with the grade example, where if I'm expecting you to enter a grade, I'm expecting you to enter something, that's the presence check, that it is an integer, that's the data check, and that it is in a range of 1 to 12, and that is the range check. And we looked at a basic example. I think it was checking if a cell number was entered correctly. So that was Friday, and today we're going to just continue. We're going to do one more example of a range check. And that's going to be a little bit of a complicated one, so you've got to concentrate pretty hard. We're going to check if a date entered in 3 edits. In other words, the one edit is for the day of the month, the second one is the month, and the third one is the year. And we're going to take that in a function, send those as parameters to a function, and this function is going to return true or false and check all those values um, if the month is indeed valid, because some months are 30, others are 31, and then you've got to look at the complicated part of February that has a little change every 4 years. Okay. And then after that, we should have time for that. We're going to do a checksum validation. And the basic idea is that helps you check if there are any errors that's entered into a number. Think of those tools. If you go to a Checkers and there's no barcode scanner, or it doesn't work, the thing doesn't want to scan, they quickly enter the barcode number in there, and they do it very, very quickly. What if they make a little bit of a mistake somewhere? And that's what the checksum is all about. Right. And then if we have time, we will look at a Delphi activity that will encompass everything we've done on Friday and today, and expect us to create a few functions, and the functions combined will help us check if an essay ID that was entered is indeed valid or not. So quickly, we did this on Friday. What is validation? It is to ensure that the data that was entered in the app is what is expected. And yes, it is a safeguard against incompatible types, because if you type in the wrong thing, the program may crash. A runtime error may occur. And as I said, it's just to determine if data is valid, not whether it's accurate or not. That's the job of verification. And then there are different validation techniques that we explored on in Unit 6.4 of the DBE Grade 11 theory. Why did I say theory here? That's not right. That's the practical textbook. Guys, this is my mistake. It's the DBE Grade 11 practical textbook, Unit 6.4. If anybody picked that up on Friday, my apologies for that. And we're just going to carry on with the next example. So this is the very big algorithm or piece of code that checks whether date entered is valid or not. I'm going to split it up into two sections, and I'm going to split it up just about there where my mouse cursor is right now. So let's just go to the next slide where we got it zoomed in a little bit. Okay, so I've got a function that I've declared, and I'm asking is valid date. So whenever I say is something, I'm probably expecting that I'm going to return a Boolean. Remember, it's a function, so I have to return something. So I'm going to return a Boolean. What does that mean? I'm going to return either true or false. And in the program that calls this method or function then uses that true or false to decide how to proceed from here. Okay, so if it's false, it's going to say, whoops, there's a problem. Try again. If it's true, it's going to carry on with the task at hand. Okay, so what we have here is there's three parameters: S day, I month, S year. Now, guys, I'm going to follow on with what the textbook does here, but I'm going to start by commenting as I go along, and I just want to make sure I didn't add my chats here live. So please, if there's any questions, anybody joins late, any questions, just comment in there. Decide whether I'm correct or not, whether you agree with me. But I'm going to start by saying that if I had to make this is valid date, I wouldn't confuse the user by making, you see, this S day is of type string. So that would be like, let's say it's today's date, the 25th of May, 2020. It wants me to pass the 25 as a string, which is okay. But then it's expecting me to send the month, the 05 or the 5 as an integer. And then the S here, it returns to a string again. Now, I would caution against that. Rather decide if the data is relevant to each other. In other words, I'm passing three variables, three parameters that are each representing a different part of the date. Don't confuse people. Make it either integer or string. However, if the parameters have nothing to do, they're not related. In other words, I'm sending name and age. Now, those aren't directly related in any way, other than the fact that they describe this person. Then, absolutely, name has to be a string, and you can choose how you're going to do the age. Maybe, possibly, best idea is to make that an integer. But in this case, stay away from confusing the person. They're just going to make a mistake somewhere. If I, for some reason, want in my function state to be a string, then convert it to a string in the body of your function. So please just, maybe that's just an unspoken rule. I didn't specifically say that on Friday, but caution against choosing the types of your parameters. Anyway, let's carry on. We will work with that. Let's see. So I've got a variable b flag. So I'm assuming that is what's going to get a value based on whether this date is valid or not, and it will return my result would become b flag in the end. And then for some reason, this person created an MM and a YY. I'm assuming it's month and year of type integer. So the first thing that this person does is it takes the parameter I month and assigns it into MM. Now, why? I'm not quite sure why. The only thing I can think of is to reduce the size of this if statement over here, that it's not cluttered, but that is not necessary. But anyway, MM is the month. And again, if I take today's date, it's going to be 5 or a 05. Well, it's an integer, so it's going to be a 5. This person starts off with B flag becomes true, which is good. This person assumes the date is valid until or unless I can prove otherwise with one of my rules. So he starts off by saying if month is 4 or month is 6 or month is 11. Why? Let's look at the next part. He says, okay, if that is the case, check if the day of the month is greater than 30. So I'm now starting to think, oh, right, what is month 4? That is April, and April is 30. But look here, April, June, that's correct. And then November. Do you see what I'm seeing here, guys? Looks like they've forgotten about September here. So when you do this, make it if, and you will be asked to do this at some point in an exam between now and the end of next year. So please pay close attention. So you would have wanted to say if month equals 4, or month equals 6, or month equals 9, or month equals 11. Okay, so that's the first mistake here. Then it says if S day of those months, okay, so if that is true, is greater than 30, then we know there's a problem. We already know this is not a valid date, okay, because there is no such thing as the 31st of April. Then what do? They do this mistake again that I don't like. They send a show message directly from the function. Never do this, guys. Please don't do this. It reduces the functionality of the function here. Let the form decide how it's going to send the message. But okay, let's assume this is just there for the time being for testing purposes. Okay, and that the person just forgot to remove it at the end. So what do? What the most important part is here is we make the flag false, so that we return false because we've proved that it is not B flag is true. It's not a valid date. So that's the first part that we've done, and that's the first check for those months. Okay, but it carries on. So I'm going to go to the next slide. Now, after that, they say now a new if month equals 2. So in other words, if month is February, now we're going to start thinking about leap years and stuff. Any comments on this? Is this a good line? Is it fine? Yes, it will work. But let's just go back one step again. If I'm asking if month is 4 or 6 or 9 or 11, then why not just say else if? Just my question. Else if month is February. So if it's not those, only then do you carry on. Because what if it was? What if it was month equals 4? What if month was 4? Then it would carry this through this if statement and then check that. And let's assume that everything was fine. It was the 25th of April. Then I know month is not 2. Why waste another cycle to check if month that we've already established is April or one of the others? Why check again? Why waste energy? Why waste processing power? So rather in a case like this, go else if month equals 2. Okay, but anyway, this will work. So else if month equals 2, then what are they doing? They're getting the year from S year. So S year was a string. And so they're getting by going string to int S here. So now I've got my year as an integer. And there's my little if statement where it says, okay, if year mod 4 equals 0, what on earth does that mean? Okay, mod is a modulus operator that we find in programming that you won't find in maths. And mod really does, for those of you who don't know, is it says, okay, if I take this value, okay, assuming it's 1990, if I take 1990, and I divide it by 4, and there's no res, there's nothing left over, okay? What is left over? That gives you an answer. So 4 mod 4, 4 divided by 4 is 1. I throw away the 1, I don't care, but I want to know is if there's something left over. Let's look at another example. 5 mod 4. So in other words, 5 divided by 4, what is left over? 1. 6 mod 4, what's left over? 2. 7 mod 4, what's left over? 3. 8 mod 4, what's left over? Then 0 again. Okay, so what I want to know is, can 4 divide exactly in year? And that's the rule of a leap year. Well, it's a little bit more complicated than that, but for the most part, every 4th year is a leap year. So for the basic calculation, that should be fine. You can go and Google the exact calculations for what if it lands on a century and a millennium and so on. But we're fine with it. So if my year is completely divisible by 4, in other words, that answer 0, 0 equals 0, then what? So I have a leap year every 4th year. And then what do I say? Okay, if it's a leap year, if my day is greater than 29, then I'm not happy because February leap year is 29. So 30 or 31, that is not correct. So if that is the case, then we say B flag is false. And I've just proven that it is not a valid day. And I will end up returning B flag as false. Okay, so that is correct there. Then it says end and then else. So in other words, else is based on this if statement over here. So in other words, what if the year is not divisible by 4? If the year mod 4 will not give you 0, it will give you 1, 2, or 3, then it's not a leap year. So what are we doing here? They say if not the day equals 28. In other words, if the day is not equal to 28, are you happy with this if statement, grade 11s? Think? I'm not. I think this is an error. Look at the leap year one where we said if day is greater than 29. Now I've got an else, and now I'm saying if it's not 28. What if it was the 25th of February? If it was the 25th of February, then this would be, well, that would be false, and the not would make it true. So the only valid date in this if statement is the 28th of February. So that's correct. That equal should be a greater than 28. Okay, so there's another little mistake there. Hope that makes sense to you as well. But okay, let's assume it said greater than 28. Then we make the B flag false, and then we are happy with that. And right at the end, we return result as being B flag. Okay, so it's a good algorithm. It's got some errors. Hopefully you picked up on the errors. One thing that you could possibly do is maybe build in some exit flags. The moment I'm false, we go out, although there's not really much of a loop here, so it's okay. Just try and not test and test and test again if you've already concluded that it's false. I don't have to prove a date false 3 times. I can do it once, and then it's done, and I can return my flag. I hope this makes sense to you all. Okay, that was quite a complicated one. So those are your range checks types of validation, and you will get them whether you like it or not, but it's not too bad if you concentrate and just keep with your problem solving here. So the next one, the last validation check type that we will tackle is the checksum type. Now, let's see what they say about it. I'll read that. It says a digit in a larger number representing the result of a mathematical algorithm applied on the other digits in that number. Oh, wow. Does that make sense at all? Okay, let me try and translate that into English. It says, I've got a big number. One of the numbers, one of the digits in that number, usually, almost always, the final digit, okay, is used to check if the other preceding numbers, in other words, from number 1 to length minus 1, if they were correct, because we're going to apply a mathematical algorithm with some calculations in there and using every other single digit in that number. And my final answer will be a 1-digit number. And that is the final check digit at the end for my checksum. So if I make a mistake on any of the numbers in that number, if I entered something incorrectly, and we'll look at some examples just now, then my expected result of my check digit of my algorithm would be different to the actual one, because now I've got a different number that I've typed in incorrectly, and I'm going to produce a different number, different answer, and they're not going to be the same. And that's another way to check, to do a validation. All right. So why do we use it? It is used to detect errors in the other numbers. For example, if 2 digits were accidentally swapped, okay, transposition, what they call that, of 2 digits. So maybe digit 3 and 4 was accidentally swapped around. Again, think about those ladies at the till at Checkers. They type in very, very, very quickly if the barcode scan doesn't work. What if they accidentally swap 2 things around? Now, we use a checksum to pick that up. It can't tell you where you've swapped, but it will tell you that something went wrong. Please try again slower. Also, an incorrect length entered. If sometimes you duplicate a digit, okay, quickly you type in the digit 3 twice, okay, or you forget to enter one of the digits, so your length is going to be incorrect. It's going to be either too long or too short, and it checks for that as well. And then also, if one digit was incorrectly entered, an example, a 5 instead of a 2, especially if people read from a very badly copied document. Some of the digits sometimes look like each other, like I think about 5 and 2 and 4 and 7 and perhaps 8 and 6, or sometimes 6 and 3. That it's sometimes difficult to check, and the person types in either mistakenly or reading incorrectly and typing in the incorrect number, and then this checksum is used to say, oops, try again, double check. Okay, so the example of a checksum algorithm that we'll be using is called the Luhn algorithm. I hope that's how you pronounce it. That's how I've always read it. It's named after its inventor, some guy with the surname of Luhn. It's also known as the mod 10 algorithm because right at the end it uses a mod 10 calculation to get that final digit. But anyway, what does it do? It's a simple formula, a checksum formula used to validate the variety of identity numbers, such as credit card numbers, EMEI numbers. Those are the numbers that each cell phone has that uniquely identifies them, as well as SAID numbers. And that's the example that we're going to look at in an activity. And what does it do? It detects any single digit error. Okay, I've typed a 2 instead of a 5, as well as almost all transpositions of adjacent digits. Okay, so digits that are next to each other that I've accidentally swapped. So in order for this to work, you've got to think here already is that something's going to happen differently to all the odd numbered positions versus the even numbered positions. I'm going to have to do a slightly different mathematical calculation on them. Otherwise, I'm not going to pick up a transposition. But we'll look at that after this. So here's the actual algorithm. So first step is the Luhn algorithm for SAID numbers. It's the same for all of them. It's just that the length of the number may be different, or of the different types. They could have a different length. So it starts off with for specifically the SAID numbers, it says, okay, the first step, A, that's a number or that's a variable, equals the sum of the odd position digits, in other words, positions 1, 3, 5, 7, 9, and 11, excluding the last digit, the 13th digit, because the 13th digit is not part of my calculation. That's the answer that I'm going to get at the end. So I'm going to use that 13th digit to compare with the answer that I got. If it's the same, then I know that 99.99999% of the times that I've entered this number, it was correct. If they differ, then there's some error that happened. Okay, so that's the first one. A is take the odd positions from 1 to almost at the end, not the final one. And what am I doing with them? I'm adding them together. Okay, so that's A. Then B. Now let's look at the even numbers. They say the concatenation of the even position digits, positions 2, 4, 6, 8, 10, and 12. Now what's concatenation? Now that's just a term that means that bring strings together, okay? Bring parts together. So if I add a value of 4 in position 2 and 5 in position 4, and I concatenate them, I bring the 4 and the 5 together, I end up with 45. That's just what it is. I didn't sum it, I just joined them together. So that's B. So that's the concatenation of that. Then C is now take that concatenated B and multiply it by 2. Okay, and then after that, take every single digit in this multiplication answer and sum them. Okay, so that's the next thing. So that's a big difference between the odd and the even ones. What is it? The even ones, they were joined first, then multiplied, and only then did I get the sum of those, of every single one of those numbers. Okay, so that's that. Then we take D is A plus C, because remember B was used to calculate C, so D equals A plus C, and then Z, that's my answer, is basically 10 minus D modulus 10. In other words, take the answer of D, divide it by 10, the remainder is then subtracted from 10. Okay, does that sound a little bit complicated? Guys, you don't have to know this. You don't have to memorize this. When you get to an exam and you have to answer this question, they will give you this algorithm. They will give you steps similar to this. You just have to stay focused, take one step at a time, and code it to get to your answer. That's all you have to do. So in the light of that, it's not too difficult. These are basic calculations, and it's going to be quite a lot of marks that you could get if you do that. Okay. So here's the example. So it's always good to look at an example. So there's an ID number over there. It says they calculate the checksum digit for the ID number that. So that is my 13th character 8. So what do? We say A, take every odd position. So it's the 8 plus the 0 plus the 2 plus the 5 plus the 1 plus the 0. We don't worry about that one. My answer is 16. Okay. Then we take B and we take the even numbered ones and we concatenate them. See the 8, 1, 3, 1, 1, 8. Then we multiply it by 2. So there we go. That's the multiplication by 2. And then we also summed those digits. So we said 1 plus 6 plus 2 plus 6 plus 2 plus 3 plus 6. And we store that finally into C, okay, which is 26. So I've got an A that's 16 and a C that is 26. And then for D, I sum A and C and I get to 42. And then finally, I work out my check digit at the end. So I'm saying 10 minus 42 modulus 10. So what is 42 modulus 10? What 10 goes into 44 times what is the remainder is 2. So I'm saying 10 minus 2, which equals 8. And that 8 corresponds with my check digit. So when I create an ID number for a new user, we look at the year of birth, the month of year birth, the day, the 23rd of January, and then the 5 if it's a male, 0 if it's female, and then the 111 is probably the 111th person to manage to, or newborn to be registered in the Home Affairs database. The 0 meaning that the person was born in South Africa and is a South African resident, and that 8 is pretty standard. That is much just there. It was just there for historical value, if I remember correctly. And then we just enter that part, and then this calculation determines what is my check digit and places at the end. There's your ID number. Okay. So that is my check digit. So what we're going to do now, and there's a bit of a problem that it is now just past 4:30. It's 4:33, and now we have to start our activity. But let's at least read and see how far we get here, because we still had another 12 minutes, so I could possibly do my first couple of questions. So activity 6.6 in my grade 11 practical book is validate SAID, and we're going to implement a few functions, and together they are going to calculate or determine whether a SAID is valid or not. So I'm going to run through this because I think I've already explained it in the previous slide. So a South African ID number is a 13-digit number that is defined by the following format. So there's my year of birth, month of birth, the day in the month of birth, and okay, so there's my birth date. Okay, so 13 March 1998 would be, well, I dropped that 19 or the 20 if you were born in 2003, we just dropped that. So it's the 98 followed by the month March 03 followed by the day 13. So that's the first 6 digits. If I look at an ID number, I can determine when your birth date was. Then the next 4 digits, now we've done this in a previous activity as well, is the SSSS are used to define your gender. Females are assigned numbers between the range 4 zeros and 4999, okay, and males from 5,000 to 9,999. Okay, so I think we still are far way off where we have to start rethinking our ID numbers. If we start having more than 5,000 or up to 5,000 births of a certain gender in one day, then we're going to start having a problem, but we're not there yet. Okay, so we can determine the gender based on that number. You either use the entire number or we just take that first number there. But, you know, if it's less than 5, it's female. If it's 5 or more, it's male. The next digit shows if you're an SA citizen status with 0, denoting that you were born in South Africa. And if it's a 1, that means you were born outside of South Africa, but you love this country so much that you immigrated to South Africa, and you've managed to, after a couple of years, attain your permanent residency, and then you get your ID number. But instead of the 08 something, you are a 18 something. And then finally, what we've just spent about 10 minutes on, 10, 15 minutes, is that checksum digit, the final digit used to check that the number sequence is accurate using a set formula called the Luhn algorithm. Okay, so we are now going to continue on page 151 of the textbook, as well as the activity that is in the data files. For that textbook. I'm going to open that Delphi project as well. And by the way, at the end of this lesson, I'll give you a couple of seconds again, just so that you can take down the link to download all these files for free. Okay, so firstly, let's look at my Delphi project. So it's a form, and it expects us to enter an ID number, and then it's possibly going to validate and extract. So you're probably just going to enter your ID number there. And yeah, maybe not very well defined here, because I would probably almost think I would have to enter all my stuff here. But I think what this thing's going to do is you're only going to enter your ID number, and then it's going to work out your date of birth and put it in a nice, that format over there, and then going to print out, if I guess, either male or female, and then citizenship. Citizen status, probably some string that we would have to do. Okay, so if I go to my textbook, I can find it over here. This is where we are. It says they open the validate info project in folder 6, validate information folder, and write code to do the following. So that's where we're going to start now. We're going to start with a nice easy one, and it says there, create a function called is not empty. Interesting that they say is not empty, but that's fine. We're going to work with that. Is not empty. And this function will receive an ID number as a parameter and return a false if the ID number is empty. Okay, so if the string is empty, if there's no string in there. Okay. Maybe we should have said create a function is not empty to receive a string and return a value false if the string is empty. Okay, but anyway, let's do that right now, because this function is going to be used and called from inside my form. Okay, so there's the button event. We'll get to that later. I'm going to declare it here under the private section. So the first thing is I'm going to say, what is this that I'm creating? I'm creating a function, and we use the term function. Then, what is it called? It's called is not empty. Okay, that's the next part. And then you got to say, what are the parameters, if any? Now let's see here. It says create a function to receive some sort of ID number and return a value as false if it's empty. So I'm going to expect some string. That's what I'm going to do here, because it's easy to check if a string is empty or not. So I'm going to say, let's call it SID. Let's expect an ID of type string. And because this is a function, it needs to return something. It's got to be of a type. Like your variables that are of a type, so will my function be of a type. And my type, as I said, not as I said, let's see that it says true or false. So it's of type Boolean. So I'm just going to type in Boolean here. And semicolon. And so that's me declaring my function there. So the creation of this, or instantiation of it, I can use the shortcut Control-Shift-C, and it creates it for me if I did nothing wrong, if everything I did was correct. And it's really just a copy and paste, except for it gives you the class name in front of the function split with a full stop. Class name, that is that over there. It's also in this case the same name as my form, because this is of a type form. So there we go. So let's say, okay, so create a function to receive an ID number and return a value false if the ID number is empty. So I'm going to create a variable of Boolean, and I'm going to say b. Let's stick with the name of the function. B is not empty, so we don't get confused, and that is type Boolean. Okay, and what I'm going to ask, I just want to check if there's something in that string. So how can I check what if there's something in the string? Well, I can check the length of the string. So I can say, okay, if the length, oh, if I could spell length of my parameter, which is SID. What about the length? That's going to give me an answer of 0 if it's empty, of something positive, depending on the length of the string, if it's not empty. So I'm saying if my length, I'm wrong language, equals 0, then what? Then I'm going to say, well, then it's empty. Hey, I'm saying is not empty. So if it had something, it would be true. So if it is empty, I need to make it false. So I'm going to say result becomes false. Okay. And else, well, if it's not empty, in other words, if it had a value there, then it must be true. So then I'm going to say result becomes true. And that, in my opinion, is the entire function done. So what did we say? We're doing a little bit of a check. I'm checking the length of this parameter that was passed to me from the form, from this button somewhere. That we'll get to that later. It doesn't care what the string is. It's just checking if the string has something entered in it. If it doesn't have something entered in it, then the result is false. Okay, because then that's not true. If it does have something, in other words, a 1 or a 2 or a 5 or an 8, then my result is true. And that is what gets returned. And we will handle that later on. Okay, guys? So it is now almost time. We will then tomorrow carry on with the rest, where we're going to start by creating a function called calculate checksum to receive an ID number and calculate and return checksum digit as a string. So yes, so that's going to be, we're going to look at this Luhn algorithm again and see if we can make one like a big method, like a big function, and actually return, oh, they want us to return this as a checksum digit as a string. We'll see why. I would have thought it would be a true or false, but let's follow the way they want it to happen. Okay, so I'm going to leave you right there and hopefully see you tomorrow. And please go back to Friday if you've missed Friday's lesson. Have a lovely day. I hope the weather is good and nice on your side. And if you're in Cape Town, that it gets better. But yes, we are thankful for the rain. And see